Founded in Hull in 1906 as the National Radiator Company, Ideal Boilers have been leading the way in the UK central heating market in the low-cost homes ever since. In the 1970s, they introduced us to the Concord range of boilers, and in 1991, we got the old classic range of boilers too. In July 2009, they introduced us to these, the LOGIC range of boilers. My name is Derek Robbins from Tomcat Gas Training, and this is another inside the boiler casing on these, the Ideal LOGIC boiler range. So the boilers we're going to be looking at, this is a 2013, this is a 2015, and as usual on inside a boiler casing, we're going to start at the top and work our way down. A bit different than what we normally do, because we're going to completely strip one of these boilers because the manufacturers say we can do it in around about 10 minutes, so we're going to have a go at that. So as usual, let's just get on with it. Now as usual, let's start at the top. So this is the 2015 boiler. Now this is actually an Ideal Independent C30, so it's a 30 kilowatt, but this is, they're all pretty much the same inside. They just changed a little bit on the PCBs and the price of them really, but compared to the 2013, there's a couple of changes. First one is the horseshoe clamp that holds the flue on. This one has a screw in it, but if we look at the earlier model, this one doesn't have a screw in it. And what was happening is, if the flue wasn't secure properly, this was pinging off. So if they had a really big fall back to the boiler, this also pinged off. So to counteract that, the manufacturer puts a screw in it. Okay, so this is still in the new range now. Okay, about 3 years ago they changed this all again, but we'll try and squeeze that little changes in a bit. Next changes, in the newer version, the sample points are now in the flue. Okay, but in the older version, this is the sample point for your flue gas analysing. No integrity testing. So you could do integrity here on the newer version, but on the older one, there was only one flue gas analyzer sample point. Okay, you also couldn't put these in high and low really easy neither, whereas the new boilers you can. Okay, so that's pretty much the top. Again, the turret can move in any direction, but one thing you've got to be worried about is your sample point. You need that so you can get on it, whereas the older one, you could put them anywhere because you could still get on it. Okay, so that's the top of these two Logics. They're pretty much the same as the new one. Okay, bracket's still the same. You can't pipe up the back of these, you need a standoff jig. Even on the new one, you still need a standoff jig. So let's get these front covers off and let's have a look at the differences inside. So if we start at the top, what we have here is the fan. Okay, behind the fan you can see the burner. We're going to see all this a lot closer. This here is the flow rectification, and this one is ignition. Now what you've got here, they class this as the hot water sensor, even though it's in the heat exchanger. So that is the hot water sensor. Here is where the air comes in for combustion and it mixes with the gas there. Okay, and we come down to the gas valve. Okay, now the big plastic thing you can see here, this is the Achilles heel for the Logic and the Logic Plus in the older boilers. They're supposed to have sorted it out now. What we get is, if you open these up and you've got staining and you've got a load of water down at the bottom here, there's every chance this is cracked. Okay, again, when we strip this boiler, I'll show you, but the sump on these is its Achilles heel. And you can see the plastic sump comes off, and then this is the flue system going off up to the turret. Just to the side is the expansion vessel, and we can get on the Schreider valve pretty easy. Okay, now if we look at the older one, it's pretty much exactly the same. Okay, a few slight little differences. We've had like 3 gas valves, But other than that, everything is pretty much the same. It's only when we get down to the water set that everything starts to change. Okay, so that's the two water sets. Can you see the difference? The first difference being, in the older model, it's brass. In the newer model, it's all plastic. Okay, so sump and condensate trap are the same. Okay, pump, now we've got the ERP pumps, but in these two models, slight differences in them, but pretty much the same. Okay, it's when we get to the flow turbine and low water pressure sensors, this has all changed. Okay, so let's get these traps off and let's have a look at the differences in them so you can see everything more closely. Now, this is the new way of doing the flow turbine. Okay, so this is pretty much how it is now, and that is the diverter valve at the back. Again, we've got the plate-to-plate heat exchanger, and on the left side of the hydro block, we've got the low water pressure sensor. Okay, so that's how the new one is. Again, you've got blow off at the back, and you've got automatic air vent. So that's on the newer ones, and the brand new version's pretty much the same as this. Again, they've done some slight little alterations, but nothing spectacular. Now, if we look on the older model, you can see low water pressure sensor is here. This is our flow turbine here, and our diverter valve is on this side, which is the old standard diverter valve. Okay, you can see the brass hydro block there. You can see the plate-to-plate heat exchanger is slightly different, but automatic air vent and blow-off are at the back there, but the opposite way around now. So the newer ones are the other way around, so you can just see the automatic air vent at the back there and the blow-off. Okay, so that's the big changes in the water set. Now, what we're going to do is we're going to actually strip one of these. Okay, the manufacturer reckons we can do this in less than, or around about 10 minutes, and that is everything out of the box. So we're going to take everything out from one of these boilers, and we're going to talk about the differences and how you test them as we're doing that. So let's stop messing around and let's just get on with it. Now, to carry out this task of completely stripping this LOGIC boiler, these are the only tools I'm going to require to do this. So we have the standard Posi 2 screwdriver, we have a flat blade screwdriver, we have a pair of water pump pliers, a adjustable spanner, an 8mm open end and ring spanner, and 4mm Allen key T-bar. So these are the only tools we're going to require to completely take everything out. Okay, so let's get on with stripping this boiler completely. Now, the first thing I'm removing are these two screws, and these two screws hold the sump cover on. And what the sump cover does is it allows you access into the sump when you come to service, but it also holds the flue manifold which connects the sump to the turret in position, and you have to remove this cover when you want to remove the flue manifold. The next thing I'm removing is the condensate trap. Now, this is one of the old traps, and it has a retaining nut on the bottom here which I'm taking off, which holds the condensate trap in position. In the new ones this doesn't exist now, it's just a plastic cover now which goes on, which is moulded into the trap itself. Now I've removed the trap, I can now start taking off this manifold. Now, the sump is the Achilles heel for this make of boiler. It happens in all the ranges. This is my opinion, and I think because it's a downward burner, the actual sump couldn't take the temperature. So when we did take this sump cover off, and we ended up putting it back on, and we tightened the screws up. We ended up cracking it, because they always seem to crack in the same place. That's just my opinion on that. Now I'm just removing the fan, and the fan's just held on with this one screw and the nut holding the gas pipe on. And this fan is constructed from a die-cast alloy. There is an injector positioned at the bottom of the mixer tube. The outside diameter of the injector allows for the correct amount of air-gas mixture. The gas-air mixture is under a negative pressure created by this fan. So there are two electrical connections. One is a 230 volts AC, which the fan motor electrics convert to 330 volts DC to drive the fan, so we need that energy to drive it. The other connection adjusts the speed of the fan between 1.5 to 2.7 volts DC. This connection is known as the pulse wide modulation connection, or the PWM. The gas rate is increased and decreased depending on how fast the fan goes. Now this burner, I'm starting to take the burner off now, and the burner is manufactured from a ceramic fibre plaque and is fastened onto the heat exchanger by these four 8mm studs. Now the two at the front are a lot shorter than the ones at the back, so you can see I'm struggling to get the ones at the back off, and this is why they make them a lot higher. Now this one is easier to get off than the one I'm trying to get off now. That is a pain, so this is probably the worst one, but you don't have to take these all the way off, you just need to slacken them to be able to remove the burner, which you're going to find I'm going to struggle to do, because it's a lot easier to take the burner off when it's actually on the wall, believe it or not, than when it is laid down on its back like this. So while I'm struggling to get this burner out, we will be seeing the heat exchanger. So the heat exchanger is constructed from cast aluminium alloy. The water enters via the return pipe connection on the right hand side of this heat exchanger, and then splits into two waterway passages. Each passage travels up and down the heat exchanger 9 times before again meeting on the flow outlet, which is on the left hand side at the bottom of the heat exchanger. Now once I finally do remove this burner, at the top of the heat exchanger is the ignition electrode and the flame detection probe. Now the ignition electrode is positioned at the top left hand corner of the combustion chamber, and the spark gap should be between 2.5 and 4.5 millimeters. The flame detection probe is positioned in the middle of the combustion chamber, and if you put a straight edge across the top of the burner, it should be no more than 13.5 millimeters lower than this straight edge. So it should be between 11.5 and 13.5 millimeters. So as you've just seen, I've just removed the gas valve, and the gas valve has two solenoids that work in tandem. The voltage will peak at 240 volts DC. A typical multimeter will show a voltage reading of between 215 volts DC and 150 volts DC. This will indicate that the gas valve is working correctly at the PCB. So you can now see I'm removing these two retaining screws which hold the main heat exchanger to the body of the actual boiler. So there are two screws which hold in on this side, and there are two hooks on the back of the heat exchanger which clip into the body of the boiler. Now the next thing I'm going to remove is this, which is the return thermistor. There's also a thermistor on the flow, and there's one at the top of the heat exchanger which I call the hot water thermistor, which is a no flow thermistor, and it turns off the boiler at 105 degrees, so it's like a high limit step. Now that was the retaining clip which I've just removed on the return pipe. I expected to be one on the flow, but there actually isn't, so there's only one retaining clip. So I've just removed the retaining clip now for the diverter valve head. So the diverter valve is for heating and hot water. So when the pin inside this diverter valve is out, it's in central heating mode, and when the pin is in, it's in hot water mode. So basically in this cartridge, which this is attached to, it's a spring-loaded cartridge which you can just see here. The motor drives it in or lets it come back out to either go into hot water or central heating mode. So what happens is when you open the tap, the flow turbine then sends power to the PCB. The PCB then operates this diverter valve head and then turns it into heating or hot water, depending on whether the tap is running or not. This is pretty straightforward as that. So I'm just removing this left hand side hydro block. There's just a couple of screws holding the hydro block to the case, and then I should be able to move this flow pipe out of the way, and this full left hand side hydro block should come out incredibly easy. So if you had to work on this cartridge, you would remove this full left hand side hydro block to be able to get at all the components. But the plate to plate heat exchanger is connected to this by just 2 Allen screws. So I've now got the Allen key, just undoing the first Allen screw, and I'm going to remove this plate to plate heat exchanger. Now this plate to plate heat exchanger is dead easy to remove. It's just literally these 2 Allen screws, so 4mm Allen screws, dead easy to remove. So I'm just going to drop this down at the bottom of the boiler case, and then I'm going to remove this left hand side hydro block, so then it makes it easier for me to take the plate to plate out then. So what I'm doing now is I'm just undoing these securing screws to the right hand side hydro block where the pump is, the flow turbine and the low water pressure sensor and the pump. I'm going to take this all out as one complete unit, which again is just a matter of undoing 3 screws and undoing the return pipe which goes to the bottom of the heat exchanger. Now I've undone this nut on top of the pump, I can now take the primary heat exchanger out, so it comes out as one complete unit. So first of all I'm just going to disconnect the flame rectification lead. So there's like a little plastic junction box there to allow me to disconnect it finally. And now I'm just taking off the wire going to the no flow sensor, on this top left hand side of the heat exchanger, and now I'm just taking off the thermistor cable on the flow thermistor. So that's all out now. So literally I've got to take this pump out, right hand side hydro block and the expansion vessel, and then we should have completely stripped it. So I'm just undoing this copper pipe going to the expansion vessel. Now one thing to look out when you're changing the expansion vessels on these boilers, the actual connection off the pump is different on the newer versions than it is on the older ones. So as you can see on this one, it's still a copper pipe going up to feed the expansion vessel, but on this one it comes off the side of the pump, where the newer ones come off the back of the pump. So you've just got to watch out that you make sure you get the right expansion vessel. But the expansion vessels are the same. They're the same for the 24, 13, 35 kilowatts. There's no difference with these expansion vessels. And you will be pressurizing them to about 0.75 to 1 bar. So when you're checking them on the service, that's what pressure you should be checking in there, obviously with no pressure in the boiler. And it's literally just held on with these 2 screws, so one at the top, one at the bottom, and a clip, and then it should just slide out. And that's how easy it is to remove this expansion vessel. And so that is all the components taken out of this boiler. Now, as always, and inside the boiler casing, let's finish off underneath the boiler. So to the left, you can see this is our flow outlet, and you can see there is a pressure gauge. Now on the brand new models, this pressure gauge has been moved to the front casing of the boiler so you can see it easily. Next, we've got the hot water outlet. Then we've got our gas with our inlet test nipple. Next one we've got is our cold water and our return with our integral filling loop. Now, this is actually a replaced filling loop on this boiler. Originally, this would have been different. This would have had a silver filling loop, and there would have been another valve on here. The other thing with these valves is as well, is when they're up like that, it means they're on. And when they're in the horizontal, if I can put them on the horizontal, they all seem pretty stiff. Got there in the end. That's off. So, well, it's actually sending it through to the filling loop. So you have to watch out for that. So that one's on though and that one's off. So anyway, they're slightly different. So it kind of catches you out when the first one I ever fitted of these, it kind of caught me out that. So anyway, you can now see this is the condensate, and you can see the trap, but this is the newer version trap, so it doesn't have the nut on the bottom. And at the last bit at the back is our blow off, and this here has been soldered, but it should actually be a compression fitting. So ideal, when these first came out, used to supply this compression fitting. Now you have to do it yourself, so that would need a compression fitting. So that's the look under the ideal LOGIC range of boilers, and they're still exactly the same today, except the pressure gauge is now to the left there. And that is the end of this video. So if you've liked this video, why don't you give us that thumbs up, because it lets me know you care, or leave a constructive comment down below. If you've not subscribed to our YouTube channel yet, why the hell not? Get subscribing, because you won't regret it, and don't forget to hit that notification bell, because I release videos every Wednesday. As usual, all I've got left to say is thanks for listening, thanks for watching. I look forward to seeing you again next Wednesday. Cheers guys.